Okay, today's class will be going with association mapping, one-to-many unidirection. This is one of the most important mapping which is used extensively in projects and coding, means in all your companies. So practice this example a lot. This is the most important example of Hibernate. Okay, let's understand that. So we are going with association mapping. Cardinality today is one-to-many. Cardinality is one-to-many and direction is what? Unidirection. So this is the example we'll be seeing today. So to understand the cardinality, what is one-to-many? I'll give you an example. Okay, one department has many employees. Means there is one department and the occurrences of employees many. So cardinality means what? Number of occurrences. So one-to-many. That's the cardinality will be going. Okay. So to understand that, let's go with the database only now first. So see this. I am having two tables here. One is the department table and the other one is the employee table. Okay. So department table is the parent table. Employee table is the child table. And in department we are having two columns now. Department ID and DName. And department ID is the primary key here. In employee table we are having four columns. EMP-ID, E-name, email, department ID. Four columns are there. And here EMP-ID is the primary key. So employee table is also having one foreign key called as DMP-ID, and it is referencing department ID in the department table. So that is how these two tables are related. So this is the design of your tables now. So as I told you, one department has what? Many employees. So see, I have filled some test data here. So there is one department, one IT. Okay. So and there is one department now, and there are three employees, Tom, John and Peter, working for what? IT department. So one department has many employees. Similarly you are having what? See, two more employees. One is James, the other one is Bond. So these two employees are working for sales department. So this is the concept now. So one-to-many. This is the cardinality. Clear? So fine. Next. Now I'll give you a scenario. You got the design of the table. You got you understood how the data is stored in those two tables. All that is clear for us. Now after you understand the tables, I'll give you a scenario in a project. So take the scenario in the project now. You got on screen now. The screen, you are saying this is a UI. So you are asking the user to enter the department ID. So the user will enter what? One department ID. Either one or two, whatever you want. He'll feel like he'll enter the ID. So once he enters the ID, now what you have to write is, this is your application now, you have to write the code. So you have to connect to the database, fetch all the employees working for what? Department, whatever department is ID, example 1. What all employees working for one department you have to display now. So means see, following are the employees, department ID is 1, department name, IT, employee 1, employee 2, employee 3, means Tom, John, Peter, all the three employees you have to display now. So this is the requirement now. So we have got this scenario in our project. This is our table and we want to do this now. Okay. So if you want to do this, okay, so you have to write the code now in your application and you'll connect to database, retrieve the values, and after retrieving the values, what you'll do? You'll store the values into a TOR entity. That's what you're going to do. You're going to connect to database, fetch the values from these two tables and transfer the values into the TOR entity. So let us see how the entity or TO will be designed now for these two tables. Clear? So very simple concept. So this is a scenario now. So we are trying to understand the concept now. Yes. So let's come to the entities now. So these are the two entities, okay, which will be representing what? These two tables now. First, let's go to employee now. Okay. So you have got the employee entity here and it is having three properties: EMP-ID, E-name, email. Okay, these are the three properties of employee, and these three properties we are mapped to these three columns now. EMP-ID is mapped to EMP-ID column, E-name is mapped to E-name column, email is mapped to email column. That's how you are doing the mapping now. Yeah, fine. Now let's look at the other entity called as department. So in department we are having two properties now. This one, department ID and DName. One more third property is there, but first I'll discuss these two properties, department ID and DName. This DPT ID and DName are representing these two columns now. So everything is fine now. But in the department, if you notice, here I am having one variable called as employees. This is a variable of type what? Set. java.util.set. Yeah. So set employees is a variable of type set, and I'm using generics here. Okay, means this set will hold only employee objects. You're having employee now, only these objects it will hold now. So this is a generics what we are using now. Fine. So this extra property has been added. So why we are adding that extra property? See, it is a very simple relation what we are going to build. There are two entities now. One is department and other one is employee. You have to relate these two entities, or you have to associate these two entities. So you have to associate them with has a relation. So just first get the statement. Department has employees. Yes or no? So department has employees means what? So obviously the set will be a instance variable in department now. Yeah, department has many employees. So you're going to have the set as a instance variable in department now. Fine. Set employees will have it now. And you're having the property. But this property, now just observe this. This property will be mapped with what? The foreign key now of what? Employee table. It will be mapped with the this particular foreign key of employee table. This is how it will be mapped now. Okay? So always remember this. See, we are working in two worlds. One is the relational world, other one is the object oriented world. So from the relational world we have to fill the data into our objects. So there is a huge gap here, and data will be transferred automatically. Hibernate will take care of it, but you should know how to design your entities. So in relational world, always the relation between two tables, we go with ID, means primary key, foreign key and all that. That is database terminology or relational world terminology. But in the object oriented world, we talk about what? Objects, references. So we use this terminology. So that's what you are seeing here. We are going to have the reference of all the employees which are stored in a set. Department will have a set which will store all the employees. That is the idea here. Clear? So once you understand how the entity is designed, now it's all about what? Mapping. Okay. So rest-all mapping is very simple here. What? These three properties with these three columns, these two properties with these two columns. Only one property you have to just focus. The set will be mapped with the foreign key of child table. Clear? And for doing that mapping, what will happen is, see, this is the most important tag now. Okay. So this is the most important tag when you are doing one-to-many cardinality. If you want to do one-to-many cardinality, okay, then this tag is very, very important. Which tag? This one-to-many tag. So now see, I have written here department.hbm.xml. So other two properties will understand how to do the mapping. It's very simple. Department ID and dname. I have just written one tag for which one? Employees. How you are going to do the mapping. Clearly understand this. So the one-to-many is going to be used to refer to the foreign key. Always remember, see, in one-to-many mapping, you will use one-to-many tag to reference the foreign key. In many-to-one, if you want to reference the foreign key, you will use many-to-one tag. So the tags are very simple. In one-to-many mapping, for foreign key we use one-to-many tag. In many-to-one mapping, for foreign key referencing, we use many-to-one tag. It's very simple concept. But one thing what you have to understand here is, one-to-many is a child tag of set. That is what you have to understand. One-to-many is a child tag of set. So it's a very simple tag. Let's understand now. See this. So this is how you'll be mapping this now. See, I'm just showing you how you map this property with this DPT department ID column. Set name is equal to employees. What is employees now? Property. Yeah. Next, table is equal to employee. Which is the table? This table. So this property is going to be mapped with this table, employee table now. Yeah. So then cascade is equal to all. I'll explain this attribute, but it's a very important attribute. Let's leave it now. Next, key is the tag. Key is the child tag of set. Column name is equal to DPT ID. Means this property will be mapped with what now? DPT ID column. So that employees will be mapped with department ID column of which table? Employee table. It's so clear. Okay, it's almost all self-explanatory. And lastly, one-to-many. You have to use the tag. Okay, class is equal to com.cluster.employee. So you have to use this. So if you do this much, okay, mapping will be done. Understood? But we understood the cardinality, one-to-many. But the direction now is unidirection. Unidirection means what? Let's understand the direction now. If you load the department, you'll get all the employees working in that department. But if you load the employee, you will never know he's working for which department. So here, department has complete information about employees, but employee does not have any information about department. That's why we call it as unidirection. So this arrow mark is the direction, in red color what I have written, and this is the cardinality. One to many is the cardinality. Clear? And always remember that, so to highlight only I have written, use blue ink here, because this property set will be mapped with this foreign key column. So this is all the concept. So only you have to understand what now, you understood the concept. If you see the output, you'll start understanding the concept very clearly. One example I have to give you now. So if I give the example, automatically you start understanding it very clearly now. Clear this? Shall I clear this now? Anything pending, parent, child? Yeah. Practice this example a lot, most important example, because it's the one extensively used in companies when you're working, this mapping one to many. So let's start seeing the example now. We'll be going with the 9th example. Association, see how I named the project, association, one to many, unidirectional, I am using XML. The same example, next I will be showing you the 10th example with annotation. So understand the concept in 9th, 10th is only instead of XML you will be using annotation, that's it, very simple change there, yeah? So fine. So yes, first the entities I'll show you now. See, this is the department and this is the employee. So let's see, understand employee entity first. EMP ID is there, ename is there, email is there. The same things what I had written. Department, DPT ID, dname, but it is having a set of employees. And you'll have the segregator methods. That's going to be common now. Done? And let us understand the mapping what we are doing here. Main is mapping only. So first I show you employee. Employee is very simple here. See, name is equal to com.cluster.employee, all this you know. ID name is equal to EMP ID. This is mapped with EMP ID column. Generator I am using increment. Property name is equal to ename. All this you know. Means the second property ename is mapped with ename column. The third property email is mapped with email column. So simple, 3 properties are mapped with 3 columns now. So nothing much about employee.hbm.xml, but we have to understand more about department now. Yeah, department ID is mapped with DPT ID column, that is okay. Dname is mapped with dname column, but this is the tag which I wrote. Which one? Set tag. What is the property name? Employees. Table is equal to employee. So employees properties is mapped with employee table now. Okay, and that it is referencing department ID column, and you are using one to many tag. So one to many is used for foreign key. Understood? For referencing the foreign key in one to many. So remember these 2 tags, many to one and one to many. These 2 tags are used for referencing foreign keys only, but based on scenario. One to many tag is used to refer in the foreign key in one to many cardinality, and many to one is used to reference the foreign key in many to one cardinality. That's it. Yeah. So very simple. These 2 done. So yes, first I'll create the tables now then. Clear? So these are the scripts. I've kept it here only. Tables.sql. For referencing you can use the script. The same tables I'll create now. But for creating these tables, what I should do? I'll use MySQL. So I'll log into MySQL now. I'll use the test user. Clear? And now I'll start executing the queries one by one. I'll copy and paste it. So there is no table, but always take precautions. Drop your table first. And that too, which one? Child table. First you drop. And then drop the parent table. Both the tables are not there. Fine. So next we are going to create the parent table. I'll create the department. Done. Then I'll create the employee table. So both the tables got created. Let's say run the query and check if there is any data. Select star from department. Fine, there are no records. So then select star from there are no records. Fine, this is fine now. So tables.sql, fine. So now we have to see the client code. Table ready. Understood? Entities ready. Mapping done. Yes, sir. Last thing is configuration file now. So in the configuration file you have to mention what? The location of the rest all things you know. The location of the mapping files. Both mapping files you have to mention because there are two mapping files. I am mentioning both the locations. So this is done. Last thing is we have to see the client code. Client code you have to see for inserting. See, this is very simple. Demo 1 I am opening. There are many demos here. So I am going with the demo 1. Be careful with this. Yes, here. So first I want to insert the values for IT department now. So I'll create the object of what? See the client code now. Department. Department is equal to department. Department dot set dname IT department. Now we are creating 3 employees. Employee 1, employee 2, employee 3. 3 employees have been created, which we want to insert. Now these 3 employees, see what I am doing carefully. I am adding these 3 employees into what? One set. S dot add. So add is a method of what? Set. So I'll add all the 3 employees. Employee 1, employee 2 and employee 3. Set is ready now. Now multiple employees have been stored in a set. There is one department. This is one department we are having now. Correct? And there is one set. But still this set and the department are not related. They are 2 different objects. This is a different object. The set is a different object. What we have to do now? We have to associate. See this. Department dot set employees. I'll add all the set into the set which is containing all the employees to the department. I'll add all the set which is containing all the employees into the department by calling what? Department dot set employees. Set employees is the method. Okay, and I'll send the set. So what will happen now? If I send this, it will be stored into what now? Your department object. Means in department, see your entity now. What is happening? In your entity department, employees of type set. So I called set employees. This method I am calling and handing over the set now. Means it will be initialized now. That set will be initialized. So this is what we are doing. So fine. So you are associated. The department and set we associated. Then you know how to save now. So it's very simple. See this, you get the session factory from your util class, you open the session, you get the transaction, begin the transaction and just say what? Session.save, that's it. You save the department, what happens? The parent and all the 3 child will be stored into the database. What is the parent? 1 department. And the 3 childs, which are there? 3 employees. Peter, John, and one more is what? Tom. All the 3 values will be stored into the database now. Are you clear with this? So I have to only run the client code. So focus on this code now, just immediately, and after this what you have to do, after session.save, You have to commit and you have to close. tx.commit, tx session.close. That you know. So let's run the code now. Let's see how it executes. So go and check now. Right now there are no records. So in the employee there are 3 employees which have been added, and in the department there is one department which has got added. So you just save the department. The related child also will be stored in the child table. Yeah? Fine. If you want, I'll insert one more record now for sales. Other name is what we have taken is bond. So there are 2 employees who are going to work for what? Sales department. I'll comment this. Yes. So we are having a set which contains 2 employees now, and that set will be associated with a department, and I'll say session.save. So let us run this code now. Yes, now you can see again there. Till now there were, in department there was IT department, but now sales department also has been added. And in employee you can see Bond and James have been stored. So this is how you go on to use one to many. Clear? Fine. So you understood how to work, save the one to many entities. Now let's see how to read the records. So I'll comment this. So now we'll see how to read the records. Clear? What we have stored, we'll try to read them now. See, session.load department.class new integer of 1 means I want to get all the employees who are working for the first department, means which one? IT department. Fine. I'll get the department. So from the department I can get the ID and name. That is okay. But from the department I can get all the employees now. So easy it is. See, d.get employees. Return type is what? Set. I got a set of employees. Iterate using the enhanced for loop, and you can get all the details of the employee now. Simple. So if you load the department, you can get all the employees working for that particular department. Why? Department has complete information about employee. So we are now seeing the direction. It is unidirection. Anyway, department has information about employee, we can get it now. Let's see this. So you can see there, department ID is 1, we are getting all the records now. But I actually loaded only department, but with help of department I can access all the employee details also. So that is how it is executing. Clear? One to many. And this is unidirection. Now we are seeing the direction. Okay, fine. But see, here I have commented department can access employee. Remember that. The next thing we'll see now. If I load the employee, I can load, but I cannot access the department. If you load the employee, you can never know he is working for which department, because employee does not have any information about department. It is unidirection. The direction is unidirection. Yeah? So I can load and I can get ID, name and his mail. More than that I cannot get the information. Simple. Yeah? So this is what is a basic example of what? One to many now. Okay. Put the next heading as lazy. This is a basic example over now. In the same example, see, I covered one concept is how to save a record. Second, I showed you what? Direction I showed you. Two concepts I covered. One I showed you how to insert a record, and the other one I showed you was direction. Unidirectional I showed you. Two concepts over. One more concept we'll see in the same example. Okay. Put the heading as lazy loading and eager loading. Lazy loading and eager loading. Heading is the heading now. Lazy loading and eager loading. First, understand what is lazy loading. Child objects are not loaded while loading the parent object. Means here the idea is when child objects are not loaded while loading the parent object. Means when the parent is loaded, understood? The child will not be loaded. Understood? So now let's understand. By default, Hibernate runs in lazy loading mode only. By default, when the parent is loaded, no, child will not be loaded. Understood? In Hibernate, why? Because means in Hibernate mapping file we use an attribute lazy is equal to true. That is actually the default value. In the set tag I had used lazy is equal to true. The same thing, that's the default value. If you don't use also, it is true only. It's default, which means not to load the child. The next, only parent record can be accessed. We can access only the parent record. Now the query for the child record will be executed only when the child records are accessed, and in this the database will be accessed multiple times. Means when you access the child only, then only the query will execute, and then it will hit the database and fetch the records. Understood? So I'll give you a demo on this now. Clearly see this. So we are going with what now? Lazy loading. In the same example demo only, see this. I'll go with this now. Which one? Department can access employee. Same code. What I'll do? See this here. I'll just comment this one now. Set code. Means I'll not access the child. I am loading the department, but I am not accessing the employees. So see now what is the query which gets executed. See there, only one query, that too with what? Department. So the query for employee has not got executed. This is lazy loading. Lazy loading means what? When the parent record is loaded, the child records will not be loaded now. When the parent object is loaded, the child objects will not be loaded. That's the meaning. Clear? Now when will it be loaded? When will the child will be loaded now? See this. Here. I'll remove this comment now. We are saying now d.get employees, and from the employees we are accessing the values now. Now when you are accessing the child values, now the query will be executed. Understood? So remember this is very important point. So this will help you in fine tuning, okay, your application. Let's see this. It's a very important concept. See there? Now the query gets executed. Only first select department was there. When I started accessing the child records, now the query gets executed and it is executed, and to the employee table fetches all the records and then stores all the values of the employee table into the employee objects, and employee objects will be stored in the set. So it will be done. Clear? And I am accessing the values. But when you access the child record only, then only the query gets executed. Clear this now? So this is how it works by default. So this is lazy loading. Understood? Only parent record can be accessed. The query for the child record will be executed only if the child records are accessed. The database will be accessed multiple times. Understood? Fine. Now eager loading. Child objects are loaded while loading the parent object only. As soon as the parent is loaded now, childs also will be loaded now. In eager loading, the attribute lazy is set to false in mapping file. If you want to do that, only one small change you have to do, lazy is equal to false. What a brilliant support Hibernate gives you, see. Just if you say lazy is equal to false, parent and child records will be loaded. The parent record is, yes, it's anyway loaded. The related child records are also loaded automatically now. All queries, parent and child, are executed only once in the beginning only. Only once the query will be fired. And the database will be accessed only once. We'll see the demo of that. Yeah, for that you have to go to what? Department mapping file you go. In that mapping file you change this to what? false, correct now? Lazy is equal to false means I don't want lazy loading. That's the meaning of it. So once this is done, we'll come back to demo 1. Yes, see this. I will not access the child records. I'm commenting. Yes, I'm accessing only what? I'm loading only department. But I've told lazy is equal to false. So now see what happens. From department also, query has executed. Employee query also has got executed. Both the queries have got executed. Clear? Fine. So, but we are only accessing the parent record. But both the queries have executed and the values have been loaded now. So that is the meaning of that. Yeah. The related child records are also loaded automatically. Are executed only once in the beginning, and the database will be accessed only once. Now you might be thinking, eager loading is very good because it will hit the database only once. That is okay. But you think from the memory point of view, here we are having 1 parent and 3 child records. But imagine if you are having 1 parent and 1000 child records, how many will be loaded now? And sometimes you will not need also so many. Okay. So that is why, means if you see, one side you have got database hits, other side you are having what? Memory consumption. So with experience you will understand how to balance between these two. Okay. But just I gave you the idea, and if you load all the childs like this, it will be actually what's here. Eager initialization should not be done in mapping file because it will be affected globally, and also it will consume memory in the application side. If it means we will never do eager loading. Okay. And if it means by configuring in mapping file, default value will always be what? True only. We will never change it. But if at all you want to do it, but we never do it. I am telling you when you are coding in projects. Okay. But if at all you want to do it, you can do it. But we will be doing by using. That is why we always do it while querying. There is something called as SQL. So while querying, you will do what? Eager loading. But not by configuring like this. You will understand slowly when you are doing the projects. But you got the difference between what is lazy loading and eager loading. Clear? So this is one thing what you have to understand. And one more thing, always remember. This here you are seeing only 1 parent table and another child table. But sometimes the association will be so huge, you will be working with around 10-15 tables. That time you imagine, you load 1 parent and all the child records will be loaded, means imagine the amount of data in your primary memory, that is your JVM. Primary memory means JVM. So much of data will be stored into your, or be coming into your JVM now. Simply it will be a, sometimes you start getting a result of memory error, Java errors you start getting. So that is why you should be very careful in deciding whether to go for eager loading or lazy loading. Preferred approach is always lazy loading only. Yeah, just I gave you an idea about this. So fine, close all this. Yeah, in the department, which one? In the department mapping file, we understood this attribute now. Lazy is equal to false. Now I will go with the cascade attribute. This is also a very important attribute, and most often asked in the very important attribute, and most often asked in interviews also, and it is used extensively when you are developing your project also. Very important attribute, cascade. So we start going with what now? Cascade attribute. Yes, right. Cascade attribute of set tag in one-to-many association mapping. Clear? That's the next heading now. Yes. See, cascade specifies, first of all, let me explain you the English meaning of cascade, then we'll come to the technical world. Cascade means actually waterfall, small waterfall. Understood? Small waterfall actually in English is called as cascade. And there's something, one word we used generally while in the programming world, we use a word called as cascading effect. Now what does that mean? See, waterfall means it's a very small waterfall, from the top it will come to the bottom. But in the small waterfall, whatever changes you do on the top will be reflected in the bottom. Any change you do on the top whatever you do on the top, it will be reflected in the bottom. That is called as cascading effect. Yeah. So that we'll see the same cascading effect now. Means we'll be seeing the cascading effect between the parent and the child now. Understood? Or how the what is the we'll be seeing that very clearly. So we are going to see the cascading effect between the parent and child. I'll show you with examples. You'll start understanding that very clearly now. So that's what we are going to see. This is how I explained in simple English. Now we'll start using that technically. That word cascading effect. See here the definition. Cascade specifies which operation should be cascaded. Cascaded means transferred. Simple meaning of cascade is transferred from the parent object to the associated object. Means what operations you want to be transferred from the parent to the associated object or child object. That's the actual definition. Use this definition in the interview. It's better. Okay, it's a very simple definition. Now cascade attribute has 6 possible values. So these are the 6 possible values what you can give to cascade. I had used all. Okay, the 6 possible values you can give to cascade attribute are none, save update, delete, all, delete orphan, all delete orphan. I have used all. Okay, we are going to see this. So we'll go now with means the idea of cascade is what you know now. So means see, you want to transfer some operations from the parent to the associated object. Means if I say the parent, automatically I want the child also to be, or associated object to be saved. That is cascading. One example I gave you. More we'll see with examples. It will become clear to you now. Yes, we'll go with the first value which I can give to what? Cascade. And that is none. So cascade is equal to none. I'll do in the mapping file now and I show you the output. So here if you by chance say cascade is equal to none, okay, what will happen? Saving, deleting, updating operations of the child record should be taken care explicitly. There will be no cascading effect. Till now you saw if you saved the parent, automatically all the 3 childs were getting stored. Why? Because of cascading effect. But now if you say none, you will not have the cascading effect, or the operations will not be transferred from the parent to the child. Parent to the associated object. Clear? So means you have to explicitly save parent as well as child or the associated object. So we'll see this now with an example. Clear? So first one I'll go now, none attribute, a none value for cascade attribute. So see here, so cascade is equal to what I'll do? None. First change this. Now see, here we are having the other demos, demo 2, demo 3, demo 4, demo 5, demo. So these are one example for one attribute value. So now what I'll do, I'll go to demo 2. In demo 2, see here it's very clearly written, program to give demo on attribute cascade is equal to none of set tag. Very clearly we have commented. Yeah. So we are going to give a demo on what? None. So, but first change it in the mapping file. So very simple now. See this. Same code almost all. Department object is been created. 3 employee objects have been created, but I am using the value of A, B, C. Fine. And we have created the set object. In the set I am adding all the employees. Then I will associate all these employees with the department. Association you have to do. You have to relate them. That you have to do. But while saving, see this, what you will do. One by one you have to save. Department separately, employee 1 separately, employee 2 separately, employee 3 separately. Because you don't have the cascading effect now. What you do for the parent will not be affected to the associated object or the child object. So explicitly you have to go on to save now. Are you clear with this? So we'll see this example first. I am showing you saving operation. Yeah. So yes. So for this example, it's always recommended from now on for every example you recreate the tables. Means delete all the old data. It will be very clear when you are working with the tables. So what I will do, you can copy all these queries in one go and execute it, no problem. Copy all these queries, go to what? MySQL, drop this table what you have got now. Paste it, all your queries will execute, only the last query will not execute. Press enter, that also will execute now. So execute all the queries. Means the table has been dropped now. So I'll execute select star from department, cross check, there are no records in the department, then select star from employee, also there are no records. Fine. So you got the concept now. See this, in demo 2 I'm just going to do what now? Save, but I have to do explicitly. It's very clearly written here, save operation, we have to explicitly save parent and child if you are using none. Clear? For cascade. So I'll run the code now. Yes, it has inserted, but you try to save, you do it R&D, you save only the department, which one? The employees will not be saved. You have to save it explicitly one by one. Yeah. So this is done now. So now we'll see the cascading effect of what? Delete operation. See, you have to explicitly delete parent and child. If you want to delete now, no, separately you have to delete the parent or separately you have to delete the child. Means which one you want, you have to delete it separately. Explicitly you have to delete it. So here, if I say department, if I load and delete it. Okay, 1 second. We'll see the records. See, 3 records have been inserted. So that is employee and the other one is department. We have inserted. So AA, BB, CC have been inserted into the HR department. Means they are working for HR department and the data has been stored now. So we have to see now how to delete it. So to delete it, what I'll do, I'll load the department and I'll say delete. Now what will happen now? Only department will be deleted, but employees will still exist. Understood? So see this. So in department there are no records now. Earlier HR department was there, but if you go to employee, still the records are there and the department ID will be changed to what? Null, because there is no department only. Earlier what was the department? 1, but now what has happened? Since the department was deleted, the value will be changed to null now. Clear? Fine. Now I'll delete the child, but only one child will be deleted. Other 2 childs will remain. There are 3 childs now here. A, B, C still are existing. What I'll delete which are now? A. So let us see this. Yes, select star from employee. A has been deleted. Means there is no cascading effect between parent and child. One by one you have to delete. Separately you have to. There is no cascading effect or no operations are transferred from the parent to the child or associated object. Clear this? Okay. So we'll go with the none I have to do saving, deleting, even updating also. I've shown you these 2. Updating also. Operations of the child record should be taken care explicitly. That is developer's responsibility. Now this is very interesting. If I use save update, what happens? Saving and updating of child record will be implicitly taken care by Hibernate. Only deleting should be taken care explicitly. Means here what will happen? You create your employee objects and the department object. Associate and just save what? Department. You save the department. Automatically what will happen? The department and the employees will be saved. Because cascading effect will be given, it will be only for save and update now, but not for delete. Delete you have to do explicitly one by one. So like that you can decide. Clear? Save update I'll go now. Clear? So again for this what you do, go to the, I'll close this tables.sql. Yeah, we need the tables. Yeah. So go to the mapping file first. So what is that we are going now? Save update. Correct? Huh? Save hyphen update. That's the value. Check. save update, fine. So we are going with that value now. Clear? So again what we have to do, we'll recreate all the tables. For every example you create the tables, drop and create it. It will be easy for you to trace. So again I'll go to MySQL. Fine. So the tables have been created. Select start from department. There are no records. Select start from employee. There are no records. So yes, remember that I made the changes in mapping file first, then I recreated the table. Now I'll go to the third example, demo 3. So demo 3 is having what? Program. It gives you the program to give demo and attribute cascade is equal to save update of set tag. Very clearly it is commented. Everything is same here, man. But only thing is, see, if you want to save, what I'll do now? 3 employee, 1 department I created. 3 employee objects have been created. After that, all the employee objects were added into the set. The set has been associated with the department. You have written the client code of Hibernate. That's it. So session.save means over. What will happen now? We are going to have the cascading effect. Means if the parent is saved, child also will be saved. Whatever effect, whatever, see, you decide for what operations, for what SQL operations you want the cascading effect. I want the cascading effect for only save and update operations. Like that you have to, you can decide. So session.save means if you save the department, automatically employee values also will be saved. Are you clear with this? So we'll see this now. So right now there were no records now. Did we see? Yeah, there are no records. So once I run the program now, you can see that I am saving only department, but department and employee will be saved now. Done. So let's go see this. Select start from employee, there are 3 employees. Select start from department, there is 1 department. So we are having the cascading effect for saving. Now let's see for delete. I am showing only one, only for save I'll show. Okay, now see for delete. Same thing now. We have to explicitly delete parent and child. Means again if parent is deleted, deleting parent deletes only parent and leaves orphans in child. Understood? And I'll delete the department now, but child will be still present in the employee table. So let's see, you have seen the data which got inserted here. Now I'll run and I'll delete what? Department, but still the employees will be there in the database. So we'll do this now. Done. So let's go and check now. In department no record, but in employee still records are there. Similarly I'll this one done. Means cascading effect is there only for save and update now, but not for delete. That's what I'm trying to say. I'll delete the I deleted parent, nothing happened to the child, nothing happened. There's no cascading effect for delete operation now. Okay, then fine. If you want to delete the child, that's your wish, but explicitly you have to delete now because there's no cascading effect for delete operation. So we'll run this program now. Done. A has been deleted. Done. So fine. So we'll go to the next one now. Which one? Delete. I think it's self-explanatory now. Only delete operations will be done implicitly. Means you'll have the cascading effect only for delete now, but not for save. Means if you delete the parent, automatically child will be deleted now. But while saving, parent and child have to be saved explicitly. Means you'll have cascading effect only for delete operation. You'll have the cascading effect from parent to child only for delete operation. You will not have the cascading effect from parent to child for save and update operations. Clear? Very simple concept. So let's see this. So as for doing that also, what will you do now? First go and change. I close demo 3. Okay. Go to which one now? Change it to what? Delete. First change to delete. Then next. What you will do? Create the tables. Recreate the tables. It will be easy for you. Copy it. Paste all the queries. Press enter. Drop and creates the table. Fine. So that is done. And next, we'll come to demo 4. So program to give demo an attribute cascade is equal to delete of set tag. Most all self-explanatory. See here. You have created one department, 3 employee objects. You have put all the employees into the set. Then department dot set employees. Fine. You are associating that. And see, we have to, for save operation, you have to do it explicitly. Clear? So I will go with what? Save operation now. Okay. Then first we'll see if there is any data. Did you see? No. So we'll see there. Select star from department. Select star from department. There are no records. Select star from employee, also no records. So yes. So which operation we are going now? Cascading effect for a delete operation. Cascading effect for delete operation we are going. So let's see. So I'll run now. So you have the cascading effect only for delete but not for save. So that's why I'm saving it what? Explicitly. Done. Select star from employee, records are there. Select star from department, also records are there. But delete is very interesting now. If I delete what? If I delete the department, very interesting. Cascading effect. So you are having the cascading effect for delete operation here. So means if you delete the parent, automatically it will be transferred to the child. So I am going to delete. Carefully see, I am loading which department? Department by 1 and I will delete. Done. Now let's go and see. No records in department. That is fine. But we are more interested in what? Employee. No records there also. So this is what is cascading effect. It means you can decide for which operation you want cascading effect, or for which operation you want to transfer the effect from parent to child or associated object. Clear? Fine. So this is done. So we'll close this. So then the next one will go. Delete off all. The next one what you have to go is all. Fourth one. Yeah. In all what? See this. Saving, updating, deleting will be done implicitly by hyphenate. Very simple here. Means if you save the parent, the cascading effect will be there for parent and child also. If you delete the parent, same way cascading effect will be there for parent and child. So here I have to save only the department. It will be saved. All the parent and means department and all the 3 employees will be saved. No need to save explicitly. And if I delete the department also, department and all its employees will be deleted now. So let's see that now. So first you go to what? Mapping file, change this to all. This is the one which I used while showing you the example. That's why when I saved department, automatically the child records were stored. This is the first one which I used. Yeah? Cascade is equal to all. So fine. So for that we will go to, okay, again what we have to do? Create the tables. Run all the queries every time. Yes. Select star from department, select star from employee. Fine, there are no records. And in mapping file have we changed? Yes, it is all now. Save it. Yes, now we'll go to demo file. In demo file, see this. Program to give demo on attribute cascade is equal to all of set tag. Fine, we have got the department created, we got the employee objects created, all the employees have been added to the set. Okay, then the set is associated with the department. Fine, but very simple now. Session.save will save parent and child, because we are giving the cascading support, means operation will be save, update and delete. Operation are cascaded from parent to child. So this is one what we have to see now. See, saving parent will save both parent and child implicitly. Yeah, done. So let's see the records. Employee, there are records, as well as in department also there is record. Fine. So now we have to see what? Delete effect. So if I delete the department, employees also will be deleted. Notice I am deleting only the department now. Great. See, employee as well as department has been deleted. Go and check. Department no values, as well as employee also no values. This is the cascading now. Fine. That is done. Next one will go. Delete orphan. Very important, very interesting also. So if the child record values, means child objects in the Java side, means in the Java side what you will do? You will detach or disassociate from the parent object. The child record is automatically deleted by Hibernate in the database. So I will be going to delete orphan. Clear? So for understanding that, delete orphan. So first I will insert the record, then I will come to explain this point to you. So yes, we want to change it to what now? Delete orphan. So again I will go to cascade, change it to what? Delete hyphen orphan. Done, delete orphan. So again what we have to do? Create the tables. Tables have been created. Select star from employee, no records. Select star from department, no records. So two new tables have been created, and in the department mapping file I have changed it to delete orphan. Fine. So let's come to demo. Yeah, 5, demo 6. This is over. We go to demo 6 now. Yes, sir. See the heading. Program to give demo on attribute cascade is equal to delete orphan of set tag. Yeah, same story. Department object created, 3 employee object created, 3 employees you have put into set. Department has been associated with employees, that is okay. Transaction dot begin. Yes, if you want to save, do the save operation now, when you are used to delete orphan, should be extremely little cautious. So here you have to do it explicitly. Means separately you have to do. If you are using delete orphan, this is okay. See the save first. We have to explicitly save child first here. When you are saying now, first you have to here in delete orphan. First preference means first you have to explicitly save child first and parent next. So I am saying all the child first and then the parent. Means department is last here. Employee 1, employee 2, employee 3, and then the department. So first I will save it. Yes, now we will go and see select star from department on record is there, and select star from employee also 3 records are there, fine. This is okay, but we are more interested in this delete orphan. See this, I am loading the department. Yes, the parent record has been loaded. Parent record has been loaded now. After loading it, I'll get the set of employees. How will I get the set of employees? D dot get employees. As soon as I get D dot get employees, the return type is what? Set only. Means I'm getting the set of all employees. Now S1 is a variable of set. Understand now? Now I'm calling the clear method. Clear is a method in what? Set. Java.util.set. It is a method. Clear is a collection method. Understood? If I call that, so in the primary memory I am detaching the child with the parent. I am detaching it in the primary memory. So I am detaching it, that's all. Okay. If you just detach it, what will happen? In the database also it will be deleted. So understand this point. First I will show you the output, then I will again explain you. See this clearly now. So we are going to, I'm just saying clear, I am not deleting anything here. Clear is a method of collection. So my intention is what? Detaching the association of employees from the department. I'm just detaching the association or relation now. So fine, let's see this now. So it has deleted. See, delete from employee. Fine. So let's go and check now. Select star from employee, no records. But select star from department, record is there. We only detached or disassociated the child from the parent. We never deleted any record here. Understood? We never deleted any. Where I have deleted? I am calling clear. Clear is a method of collection. That's very important now. Okay. So what does it say? If the child record values, means child objects in the Java side are disassociated from the parent object, the child record is automatically deleted by Hibernate in the database. Means so in the department object, yes sir, in the department object, what are the different values we are having? We are having department ID, that is okay. Then we'll have department name. Then we'll have set of employees. So employees is a variable of type what? Set. Department ID value is 1. Dname value is HR, that is okay. But this employees is referring to one set object, yes or no? And in the set we are having what? 3 employees. We are having 3 employees here. We are having employee 1, we are having employee 2, we are having employee 3. This is how it has been loaded from the database into primary memory. Clear? So here what I'll do is I'm calling employees dot clear. If I call the clear method, clear is a method in collection. So actually it is removing means removing all the values in the set. But if you do so in the database also, here this is Java. Understand now? This is Java program and this is database. If I disassociate here, the values are deleted in the database also. That is what you mean by delete orphan. Yeah? So this is how it works. So this is one more important feature now. Clear? So that's about delete orphan. Now I think the last one, all delete orphan. You should have got the idea. It's a combination of what? All and delete orphan. It's a combination of 2 things, all and delete orphan. Clear? So all delete orphan is a combination of 2 things, all and delete orphan. So to understand that, you just understand this diagram now, you'll automatically understand that. You have got save update now. This diagram you understand now. You got save update and you got delete. Yes. If you want both this support, what you'll do? You can go for all. That's it. So all is including what? Save, update and delete. Fine. Then one more you are having. What is that? Save, update, delete orphan. This is one more which is having there. You are having. Which one? Delete orphan. Okay. Yeah, we are going with this one. All delete orphan. Is a combination of all delete and all and delete orphan. Yeah. So now one more thing. Clearly understand this now. There is one more which we are going to learn now. That is what? All delete orphan. That's it. Simple diagram I have given to you, where you understand all the cascading effects very neatly. Clear? So save, update is separate, delete is separate. If you want both, go for all. Clear? Fine. Delete orphan is almost separate. If you want combination of everything, go for all delete orphan. That's it. So all delete orphan is like this. One diagram I have given to you. Clear now? So I have not given any example for this. You can do the change in what? Hibernate mapping file, and you can try doing all the same things which I have shown to you. So today, summary, what we have covered? We saw one-to-many cardinality, unidirection, and we saw what is lazy loading, eager loading, and finally we saw what is cascading effect. So these are the means in the set tag, two important attributes what you have to understand are lazy and cascade. Clear? So I covered this much. So these are very important interview questions now. Fine. So this is the thing what I did till now. So yes, demo 6. So this is done. So I am not having an example for all delete orphan. You do it. Yeah. So you understood the concept of what is one-to-many and all that you have understood. We saw one-to-many cardinality, unidirection with XML. Now the same thing you have to see it with what? Annotation. Almost all everything same here. Only one thing what will changes means the cardinality, unidirection, everything will be same. Okay. Only thing is you will be using instead of XML annotation. So I am going with the 10th example. One-to-many, unidirectional, but with annotation. Simple. So here you will not have mapping file. Clear? Hibernate mapping files will not be there. I am having employee, means the tables are same, no change. We are having employee and department. So first I will open employee. Very simple class. You know these annotations, entity, table, means this entity is mapped with employee table. And then for EMP-ID it will be mapped with EMP-ID column. I am using primary key auto generate. Then get name is mapped with ename column. Ename means ename is mapped with ename column. Email is mapped with email column. So employee is very simple, nothing much here. Only change is what you have to understand is in department you have to understand. So in department, let's see what has happened. Very simple here also. This is same entity table. Okay, you are having the set of employees. So for department ID what you do? For primary key use @ID and @generative annotations, @ column, you are mapping this with department ID column. That is fine. Now department name is mapped with dname property. That's also fine column. But here only two annotations you have to understand. It's very simple. In annotation, one-to-many you have to use. Cascade is equal to cascade type dot all. Okay. @join name is equal to department ID. Means you are telling which it should join which column. It should join department ID column. That's it. One-to-many tag and this one to annotate means one-to-many annotation. One-to-many annotation and @join column. Two annotations. These two annotations, remember, if you use it, annotation coding is over. Nothing much. Clear? and cascade type is a enum here. Enumeration, there are different values here. So that's it. Cascade type dot all. So you will not have the mapping file, but one more thing what you have to understand is department is there, employee is there. Okay. So in the configuration file, what you have to do? You have to specify the location of the classes. The location of the classes, and here you'll use mapping class. That's one change. Com dot cluster dot employee, com dot cluster dot department. This thing you have to do. Fine. Now only is about two things done. So I have to entities you saw, configuration file you saw, but to run this code I need what? Tables. So the tables again you can see it's here, tables.sql. I'll copy this and we'll run this query. So the tables have been dropped. Okay. So then we're coming to the client code now. We have to run the client code. So see this. So we have got the same thing now. What? Department. So on department object has been created. 3 employees have been created. The 3 employees have been added into the set, and we are associating the same thing. Everything goes same. There's no change here. Okay. And if I want my session factory, I'll be getting it from my util class, and I'll get the session. But same thing now. And all I'll be doing is what? Session dot save of department. That's it. The parent and child will be inserted, because cascade type I've used is all. So that's a very simple program now. Just you can see this output. Yes, it has been inserted. So you can go and check. Select star from department. So one record has been inserted and one more is with employee. You'll see that. Done here also inserted. So one-to-many mapping with annotations. That's it. Clear? So 2 examples we have covered. One-to-many. And this is the most important mapping used extensively in companies. I'm repeating it. Practice this a lot. Yeah, most extensively used. Why means you might have a question. Remember, always your tables are going to be designed in one-to-many manner only. Means when you are designing your tables now, so you'll go with what? How will you design your tables? One-to-many relationship only, your tables. That is why this also becomes very important. How your tables are there? Same way, from the table I want to retrieve it into the entities. So that's why one-to-many becomes very, very important. Because the extensively used database design for storing values is one-to-many. Yeah? So that's it. Nothing more.